Okay, so I wanted to record the Newton's Laws practice problem so you could get an idea of how to be successful in the test on Friday. So for 1A, you have a box that's scooted across the table. There's a force acting in that direction that's 180 newtons. There's a force pushing to the right, and it is 300 newtons. So I need to get the net force. Well, if I just simply pick this one up and slide it over here, that's 180 newtons. Now I have them head to tail, so I can solve for the net force and that angle. So net force is going to be the sum of all the forces. They're at right angles, so I'm going to do Pythagorean theorem. 300 newtons squared plus 180 newtons. And when I did that, I got 349.9 newtons. And now I need that theta, so I said that the tangent of theta is equal to the side opposite, 180, over the adjacent 300. So I got theta to be equal to 31 degrees. And I'm going to say 31 degrees with the positive x-axis. However, I'm not done because now they want the acceleration. Well, the acceleration is going to be the net force divided by the mass. The net force was 349.9 newtons. The mass was given to you as 23.5 kilograms. And I should have listed that with my givens when I first started the problem, so let me come over here and do that. So my acceleration, when I divide 349.9 by 23.5, I get 14.9 meters per second squared. And the acceleration will be in the direction of the force, which is 31 degrees with the positive x-axis. So there's part A of number 1. Part B says that I have two forces that look something like this. This is 133 degrees. That makes this angle be 47 degrees. I know that this is 110 newtons. I know that this is 230. So I'm going to make an XY chart because I don't have any right angles, so Pythagorean theorem won't do me a bit of good. My X is 230. It's to the right, so it's positive. There is no Y. This one has a component acting in this direction, which I'll call Fx, and a component acting in this direction, which I will call Fy. I'm going to say that the sine of 47 degrees times the hypotenuse of 110 will give me Fy. When I did that, I got Fy to be 80.5 newtons. And it's straight up, so it's a positive 80.5 newtons. I use the cosine of 47 degrees times 110 newtons to give me Fx. Cosine of 47 times 110, I got Fx when I did it to be 75. It's to the left, so I need to make that negative. Now I'm going to add up my x's and my y's. Well, when I added up my x's, I got 155 newtons here and 80.5 here. Now I need to show my work to get my F net. My F net is going to be the square root of 155 newtons squared plus 80.5 newtons squared. So when I solve for my net force, I got 174.7 newtons. And then I said, well, I need theta, so the tangent of theta is going to be 155 to the x positive and 80.5 on the y, and it's positive. So here's my theta. So the tangent of theta is 80.5 over 155. So theta is going to be 27.4 degrees. And again, it's with the positive x-axis. So now I need my acceleration. So when I solved for the acceleration, I said the acceleration was equal to F net over m. F net is 174.7 newtons. Mass was still the 23.5 kilograms that we had in part A. So my acceleration was 7.43 meters per second squared, and it's still in a direction of 27.4 degrees with the positive x-axis. So there's number 1. If I go on to number 2 wants to know what is the weight of a mass rock that is mass of 65.8 kilograms. Well, I'm looking for gravity to be 9.8 on the Earth for part A. And for part B, I'm going to go to the moon where the gravity is 1.67 meters per second squared. So the formula for weight is weight equals mass times gravity. I will give you the formulas on the test. Mass is 65.8 kilograms. Gravity is 9.8 meters per second squared. So the weight that I have right there, when I did the math, I got to 644.84, 644.84. But when you look at the significant digits, that rounds off to 645 newtons. And then for part B on the moon, the weight is equal to mass times gravity again. The mass is still 65.8 because it's the same rock. And gravity is 9.8 meters per second squared. So my weight is 109.9 newtons, but I want it in significant digits, so I'm going to go with 110 decimal place newtons. Alright, I'm going to stop this recording and then I'll go on and do some more problems.